Vectors in the plane. This video is about vectors as the directed line segments, component form of vectors, vector as a linear combination of unit vectors, direction angles of vectors, use of vectors in modeling and solution of real-life problems. What is scalar? Scalars are the quantities that can be described completely by their magnitude. Examples are heights, weight, volume, distance, speed. Vectors are the quantities that can be described by their magnitude as well as direction. Examples are velocity, force. Geometric representation of vector. Directed line segment is a line segment with a designated direction from initial point P to terminal point Q. Geometrically, vectors are directed line segments with initial point and terminal point. The length of directed line segment is the magnitude of the vector, can be found using distance formula. Component form of vector. Vector in the standard position. A vector V that has the initial point at the origin is called the vector in standard position. Component form vector. A vector whose initial point is at 0, 0 and terminal point V1, V2 has a component form of V angle bracket V1, comma, angle V2, angle bracket, and is written as V is equal to angle bracket V1, comma, V sub 2, angle bracket. The component form of vector with initial point P, x1, y1, and terminal point Q, x2, y2 is given by this formula. Well, vector V equals to, you subtract the initial point coordinates from the terminal point, like x2 minus x1, comma, y2 minus y1. So the P is the initial point and the Q is the terminal point. The magnitude of the vector V with components, so V1 and V2, these are components, is written this way: double bars V equal to square root of V1 square plus V2 square. Example 1. Find the component form and magnitude of the vector V. So here we have initial point is 4, 1. Here 4, 1. And terminal point is Q, 1 minus 4. So the component form of, we can use vector V and write this angle bracket 1 minus 4, comma, negative 4 minus 1. Simplify, that gives you angle bracket negative 3, comma, negative 5 angle bracket. The magnitude of this vector is the square root of, you square the negative 3 and then square of negative 5. So square of negative 3 is 9 and square of negative 5 is positive 25. 9 plus 5 is 34. So it should be square root of 34. And it cannot be simplified. Let's find the component form and magnitude of the vector V, where the initial point is negative 5 and 2 and the terminal point is 3, comma, negative 1. So the component form of vector V we denote by vector V is equal to angle bracket subtract from 3 negative 5. So 3 minus minus 5. Similarly, subtract from negative 1 to like negative 1, comma, negative 2. So this becomes 3 plus 5, 8, and this becomes negative 3. So the magnitude is V, magnitude is just square root of first component square and then second component square. So it becomes 64 plus 9, 73. So the magnitude of this vector is square root of 73. Remember that to find the initial point and terminal points are given. To find the vector, you always subtract the coordinates of initial point from the terminal coordinates of terminal point and not the other way around. Here's an example 3. We're going to find the magnitude of the scalar multiple where u is equal to 3 angle bracket 3 comma 1 and vector v is angle bracket 5 comma negative 2 angle bracket. So we're going to find the magnitude of 5 times unit vector u, 5 times vector u. So we can factor 5 and we left with the magnitude of the vector u. So now we replace the u by components, this one. So you have a 5 double brackets, angle bracket 3 comma 1, angle bracket and then double bars. So we can 5 and the formula says you square the first component, square the second component and then add them together. So we have 5 square root of 3 square is 9, 1 square is 1. So it will be 5 plus 10 square root. Example 4. So we're going to find the magnitude of the scalar multiple where u is angle bracket 3 comma 1 and the v is equal to angle bracket 5 comma negative 2. So we have to find the magnitude of minus 4 times v. So that's the v vector. So we're going to see magnitude of negative 4v is equal to, we factor out negative 4 in absolute value and then left with the magnitude of v. So absolute value of negative 4 is positive 4 and here we write the vector v. So now we apply this formula and then we 4 times the square root of 5 square is the first component and the square is the second component and then simplify. So it becomes 4, 5 square is 25 and square root of negative 2 is 4. So 25 plus 4 is 29. So the answer is 4 times square root of 29. Unit vector. For any vector, the unit vector u in the direction of vector is given by this formula. The v, vector v divided by its magnitude. So to find the unit vector in the direction of vector v, all you have to do is divide the given vector by its magnitude. So here is an example 5. Find the unit vector u in the direction of v and verify that the magnitude of unit vector is 1. So here the vector v is given, whose components are negative 4 and negative 8. So first we're going to find the magnitude of this one. So which is, you just square the negative 4 and square the negative 8 and then add and take the square root. So this becomes square root of 16 plus 64, which becomes square root of 80. Now we can simplify. 80 can be broken down to 16 times 5. So you can break it down this radical into 2 square roots, square root of 16 and square root of 5. And the square root of 16 is equal to 4 and the square root of 5 stays 5. So that's the magnitude of vector v. So the next we're going to divide the given vector v by its magnitude and call it unit vector u. So we have u equals to vector v divided by the magnitude of v. So the vector v was negative 4 comma negative 8 and the magnitude was 4 times square root of 5. Now we can divide individually. We write equal to angle bracket negative 4 over 4 times square root of 5 comma minus 8 over 4 times square root of 5. Now 4 and 4 cancel, so you get square angle bracket negative 1 over square root of 5 comma. Similarly 4 dividing to 8 is be negative 2. So negative 2 over square root of 5 angle bracket. Now we rationalize, we multiply square root of 5 top and bottom. So you get 5 on the bottom and you got negative square root of 5 on the top. Similarly, multiply square root of 5 here, square root of 5 here. Square root of 5 times square root of 5 becomes 5. And the top becomes negative 2 times square root of 5. So now we have unit vector, angle bracket negative, square root of 5 over 5, comma, negative 2, square root of 5 over 5, angle bracket. So now we're going to find the magnitude of this one. So this is just showing we're finding the magnitude of this vector u. And according to the formula, all you have to do is just square each component and take the square root. So it becomes square root of negative square root of 5 over 5 square plus negative 2 times square root of 5 over 5 square. So when you square, this becomes positive 5 and the bottom becomes 25. And even you square this one, negative 2 becomes 4. This becomes 5. 4 times 5 is 20. And the 5 square becomes 25. Now we can add 5 plus 20, 25 over 25 square root. Now 25 to 25 cancel, then you get square root of 1, which is 1. Finding a vector in the direction of a given vector. So let's say to find a vector v with a magnitude of this v in the direction of another vector u. So it is given by this formula. So vector v is the magnitude of the vector times the vector u divided by its magnitude. So to find a vector in the direction of a unit vector, then all you have to do is take the magnitude of the given vector and the vector in which direction you want to find vector, convert that into unit vector. Okay, step 2, we're going to find vector v by multiplying vector magnitude and the unit vector w just found. So we call this vector v equal to the magnitude of vector v times the w, unit vector. Now this is 12, so we put 12 here, and this is, we found this one, 2 times square root of 13 over 13, comma, negative 3 times square root of 13 over 13. So now we just distribute to become 12 times 2 times square root of 13 over 13, comma, minus 12 times 3 square root of 13 over 13. So to simplify, it gives you angle bracket 24 square root of 13 over 13, comma, negative 36 square root of 13 over 13, angle bracket. Standard unit vector. The standard unit vectors are negative 1 angle bracket component from angle bracket 1 comma 0 and angle bracket 0 comma 1. They are the standard unit vectors, and we denote them. The first one is I, and this is along x-axis, and the second is vector j, and this is along y-axis. And each of these have a magnitude 1. That's what these are called unit vectors, and they are called standard unit vectors. As an example 7, the initial and terminal points are given. I'm going to write a vector in linear combination form of the standard unit vectors. So let's call this u as a vector equal to, we're going to subtract, so formula is you subtract the coordinates of initial point from the coordinates of terminal point. So like ux up to minus x1 multiply with I unit vector plus y2 minus y1 multiply with j unit vector. So now x2 is negative 2 and x1 is what? 1, and then multiply with I. Similarly, you have a y2 minus y1. So we simplify, gives you negative 3i, and this should be 3 plus 4, 7j. So that's the answer, negative 3i plus 7j. And that's the linear combination of a unit vectors form. Next is direction angles. For a unit vector u as a linear combination of unit vectors I and j, the direction angle theta is given by this number 1. Vector u, if vector u lies in quadrant 1, then the direction angle theta is tangent inverse b over a. In other words, the second component divides the first component. If vector u lies in quadrant 2, then theta would be, direction angle would be 180 degree minus tangent inverse b over a. And if the vector u lies in quadrant 3, then theta would be 180 plus tangent inverse b over a. If vector u lies in quadrant 4, then theta would be 360 degrees minus tangent inverse b over a. Example 8. Find the magnitude and direction of the direction angle of vector v. So here's a vector v in the linear combination of unit vectors. So first we're going to find the magnitude. So magnitude we denote by double bars v, and we can double bar 4i minus 6j. So you just square each component without the unit vectors. So this becomes square root of 4 square plus square of negative 6. So 4 square is 16, and so this is 36, and total is 52. It becomes square root of 52. And we can break it down to 4 times 13. Square root of 4 is 2, and square root of 13. So direction angle, to find the direction angle, we draw the vector to find out in which quadrant this given vector lies. So if you see this, so like a 4 unit go to the right and 6 unit go down, and I think it should be this point and connect this one, and looks like this is in quadrant 4. So to A is 4 and B is negative 6, so theta will be 360 degree minus absolute value of tangent inverse minus 6 over 4 absolute value. So if we put on the calculator, it gives you 56.31 degrees. And you subtract, gives you 303.69 degrees. Different forms of vectors. Let V is equal to angle bracket V1 comma V2 angle bracket be a vector in standard position whose direction angle is theta, and the magnitude is square of V1 square plus V2 square. Then number 1, vector V, we can write V1i plus V2j as a linear combination of unit vectors, or we can write as V is equal to the magnitude of V times the cosine theta I plus sine theta j. That's the vector in terms of direction angle theta and magnitude. Number 3rd form, we can write this as magnitude of vector V, angle bracket cosine theta comma sine theta angle bracket closed. So here is an example 9. Find the magnitude and direction angle of the vector V is equal to tan cosine to 40 degree sine to 40 degree. So the angle is already given. So 240 degree is the direction angle, and that's the magnitude. So the magnitude of vector is just 10. Example 10. Find the component form of the sum of vectors u and v with direction angles theta u and theta v. So we're given magnitude of vector u is 4, direction angle of vector u is 60 degrees, and the magnitude of vector v is 4, and the direction angle is 90 degrees. So first step, if we're going to write vector in terms of magnitude and direction angle, so we're going to write u in terms of this. The magnitude of u, angle bracket cosine of theta u, comma sine of theta u. So now magnitude of vector u is 4 and theta sub u is 60 degrees. So we substitute this value here, so you get vector u is equal to 4, angle bracket is cosine 60, comma, sine 60, angle bracket close. Now we can find this value from the unit circle. So unit circle will be cosine 60 1/2, sine 60 degrees square root of 3 over 2, and then we distribute. So we become 4 times 1/2, comma, 4 times square root of 3 over 2, which becomes 4 times 1 is 4, divided by 2 is 2. 4 times square root of 3 divided by 2 will be 2 times square root of 3. So now we're going to step 2, we're going to write vector v in terms of magnitude and direction angle v. So vector v can write the magnitude of vector v, angle bracket cosine theta v minus sine theta v. Now substitute the magnitude of v, which is 4, and theta sub v is 90 degrees. So this is equal then 4 times cosine of 90 degrees, comma, sine of 90 degrees. So now from the inner circle, cosine 90 is 0 and sine 90 is 1. So you're left with 4, angle bracket 0, comma 1. Now I distribute 4. So the angle bracket 4 times 0, comma 4 times 1, angle bracket close. Simplify gives you angle bracket 0, comma 4 angle bracket. Now we add the vectors u and v. Just found. So u plus v is equal to angle bracket 2, comma 2 square root of 3 plus angle bracket 0, comma 4 angle bracket. So we can add just the first components, 2 and 0, and 2 times square root of 3 into 4. So 2 comma 0 is 2, and this stays 2 times square root of 3 plus 4. You don't need to use calculator. So that's the answer. Here is an example of 11. A gun with muzzle velocity of 1200 feet per second is fired at an angle of 6 degrees about the horizontal. Find the vertical and horizontal component. Find the vertical and horizontal component of velocity. So the given is the magnitude of v is 1200 and the direction angle is 60 degrees. So the vertical component we denote by v sub y is the magnitude of v times sine theta v. So this becomes 1200 times sine of 6 degrees, and then we put on the calculator, gives you 125.4 feet per second. And horizontal component we use v sub x, and that will be the magnitude of vector v times cosine theta v. And now we substitute magnitude of v is 1200 and theta v is 60, so we 1200 times cosine 6 degrees. Put on the calculator in degree modes, so we become 1193.4 feet per second.